Hi all. Let's start with the next video of PCIe. In this video, we'll see the how to calculate bandwidth in a PCIe with the different generations. As I told you in previous PCIe, we have a different types of generations. In the up to from Gen 1 to Gen 6, we have still now. So in each generation, we have a maximum we can able to achieve bandwidth will be the different. So based on the requirements, based on the how many lanes we are using to get that bandwidth, so which encoding we are using. So we'll see the all the points like how to calculate this bandwidth with different frequency and different generations. Let us take as a one suitable example for that. You have a RC, you have a EP, you have a RC, you have a EP connected to, let us assume, single lane. Single lane means one transmitter, one receiver. So let us assume I have a one lane connected with a RCTP with a PCI Express. So let us take one Gen 1. Gen 1 we have a maximum operating frequency 2.5 gigabytes per second. This is a operating frequency. So let us take as a one lane I am using. What is the operating frequency? 2500 megabytes per second. Which encoding I'm using? 8 to 10B encoding. From let us take as a from Gen 1 and Gen 2, we are using 8-bit NB encoding. From Gen 3 onwards, we are using 128 by 130 encoding. So what is the operating frequency? 2.50, one lane, we are using 8-bit NB encoding. If we take as a one direction with a 8 bits per cycle, what is the maximum bandwidth we can achieve, able to achieve? 200 megabytes per second. So simple formula, if you see in a communication, uh, RB is equal to NFS. This is a formula we will use to calculate the bandwidth. This is a sampling frequency. This is really the N is the number of counts, how many number of counts we are using, how many clock pulse. So same scenario, let us assume N will be the number of lanes we are using. What is the frequency we are using? Well, let us take as a generation and into encoding. Which encoding we are using. This is a simple formula to calculate the maximum bandwidth. So theoretically, we got a for one lane, for one direction, we have to get as a 200 megabytes per second. If you take as a both direction, you have a transmitting and receiving, right? This is a dual simplex, right? So we have a transmitter and receiver is a different. So if you take as a both direction, you have to, instead of one, you have to use two here. So what happened? 400 megabytes per second you can able to get the bandwidth. This is the maximum bandwidth you can able to get theoretically. If you take in a practically, the bandwidth will be reduced because of the errors, some latency. So we are not calculated here. We are not considering here any latency or any errors. Theoretically, we assume as a everything is working fine. This is the maximum bandwidth I can able to achieve. So this is a for both direction for single lane. If we take as a 16 lanes, what happen? So both direction. This is a Gen 1. So 8-bit NB encoding. So this is the maximum bandwidth I can able to achieve theoretically. 8000 megabytes per second. This is the maximum bandwidth. So Gen 1, Gen 2 we will use as a 8-bit NB encoding. For Gen 1 we will use as a 2.5 gigabytes per second. For Gen 2 the bandwidth will be double for every generation. So 5 gigabytes per second. Gen 3 will be the operating frequency will be the 8 gigabytes per second. So it should be double. As I told you, it should be for Gen 1 will be the 2.5, Gen 2 will be the 5, Gen 3 will be the it should be 10, but it will not like that. It will be the 8. So here frequency is 2 gigabytes per second. It's will less, but it's covered with encoding. Here is a Gen 3 we are using as a instead of 8B 10B encoding we will use as a 128 by 120 130 by encoding. So based on that what happened, the bandwidth will be double for in next Gen 3 also. So let us take one example here for Gen 3, 16 Let us assume 16 lanes I am using. This is the operating frequency 8 gigabytes per second. 8 gigabytes per second. This is the operating frequency. This is the encoding we are using for both direction from transmitting and receiving direction with every 8 bits for every clock cycle. So this is the maximum bandwidth I can able to achieve. This is the maximum bandwidth. So from in theoretically we can achieve this much, but practically it will reduce. As I told you, due to some latency, some error issues will come into picture, so that the bandwidth practically will reduce. So in this way, we can able to calculate the bandwidth of a PCIe in a different generation. If you take as a Gen 1, Gen 2, 2.5 and 5 gigabytes bytes per second. From Gen 3, 8 gigabytes per second. From Gen 4, it will go double again, 16 gigabytes per second. So Gen 5, it will go as a 32 gigabytes per second. So like that, based on that, how many lanes you are using, what is the maximum bandwidth you have to achieve, which encoding we are using. So based on that, we can able to get the maximum bandwidth theoretically. So in this way, PCA we can able to get the calculation of bandwidth. So if you have any question, please let me know. Thank you.